Hello. Hi. I'm glad the mic is working. Inspirational keynote. I've given many keynotes, but never an inspirational keynote. And I guess you're all hungry, a bit tired, and you want to go for dinner and drinks. So I try to be inspirational and not be too technical and not be too boring. I have about 15 to 20 minutes. And what I want to do in that time is three things. First, I want to talk a bit about why I call myself an energy transition optimist. When you check my LinkedIn profile, you will see that that's my main headline. So I want to spend a bit of time on why I call myself an optimist when it comes to energy. Secondly, I want to talk about heat, because I know you're all very interested in heat. I know also cooling, but I want to talk about heat a bit and how important that is. And then finally, I know we have to talk about district heating as well, right? Because this is a crowd of people who are district heating enthusiasts. So I will be doing a bit of that as well and then wrap up. So 3 parts. Let me start with the first one. But before I go into that, I'm going to show you a little cartoon, which actually I can't use anymore, I think, because it's no longer relevant. It's out of date. And that is this one. Anna used the analogy of the elephant in the room, so she's stolen that term already from my presentation. And for a long time, it was a bit like this, wasn't it? People talked about all sorts around energy. It was nuclear, renewables, CCUS, batteries, EVs, but heating was barely mentioned. That has really changed now, and in some cases for the worse. When you look at some of the debates I see in Germany, for example, last year, right? We had a fierce and very polarized debate around heat, but also in other countries, I see the same story. So heating is no longer the elephant in the room. Actually, I can't use this slide anymore. It was such a great introductory slide in the past, but I think it's out of date now, which is a good thing. I think it's good that we finally talk about heat. So now to the first part of my presentation. Why am I an energy transition optimist? And I'm going to tell you a little anecdote, which I think is quite telling. So bear with me. I'm going to show you a slide that is in German. I grew up in Germany. Some of you might speak German, some of you might not. But I'm going to explain what it says on the slide. So this is an advert that was posted by the 4 big utilities, energy utilities in Germany in the year 1993. In the Süddeutsche Zeitung, which is one of the major newspapers in Germany. And in this advert, the utilities said that renewable energy could only ever provide up to 4% of electricity in Germany. And that is wind, solar, and hydro. So if you fast forward 30 years to the year 2023, what are the actual figures going to look like? They look like this. And you can do the maths yourself. When you add up all the figures on the right here, wind, solar, and hydro provided more than 40% to German electricity. That is an order of magnitude more. So the utilities were off by a factor of 10, in other words. You might ask the question, why do I tell you this story? What does this have to do with me being an energy transition optimist? Well, I think there's a pattern here, and the pattern goes like this. We tend to completely underestimate new technologies and innovation, and we tend to overestimate the inertia of incumbent technologies. Let me put some numbers to this. So here is a slide from the International Energy Agency World Energy Outlook data that has been compiled by RMI, the Rocky Mountain Institute. I think they no longer call themselves Rocky Mountain Institute, but RMI is a term they're using now. What you see here is, in gray, the World Energy Outlook figures for solar, for EVs, and for battery cells. And you see the actual deployment alongside. What does this data tell us? So every single time the IEA has been off by a very wide margin and had to revise their figures the next year. Actually, the latest version of the World Energy Outlook came just out, I think, 2 weeks ago. It's not included in this slide, but it would show a very similar picture. Why does this happen? It's not because the IEA doesn't like solar, EVs, batteries, renewables. In fact, they are quite enthusiastic about it now. They weren't always enthusiastic. When you look at some of the reports 20 years ago, it was quite different. No, it is because models are not very good in predicting exponential change and dramatic change. That's why we see those figures being too conservative. There's also the reverse happening with energy, and that is incumbent technologies. We overestimate how long they might prevail. I'm going to use a national example now from the country where I live, in the UK. And this is a slide from a journalist called Ketan Joshi, who is a great communicator around energy and climate. And he has found that every time in October, the media in the UK, especially media like The Telegraph, I'm not a big fan of The Telegraph, you might be able to tell, they said there's a coal comeback. Coal is having a big comeback. It's not the end for coal. And what actually happened is that in October, electricity demand went up. Why is that? Shorter days, longer nights, more electricity for heating, etc. And coal-fired power plants came back online. But actually, the last coal fire station in the UK went off-grid on the 30th of September this year. So coal is gone, and it used to be about 70% just in the 1980s in the UK. Again, there will be other stories from other countries that show very similar results to what we're seeing here in the UK. And there is a pattern to it that is not just about energy. Right now, I'm reading the book here on the left by Schumpeter, who was a German finance minister and a Harvard professor. And he's written some great work, actually, about innovation and economic development. And what Schumpeter is saying is that there is a pattern in terms of new technologies coming along, and creating, it's called creative destruction. That's a term that he's using. And old technologies very rapidly can suddenly be replaced. And in fact, a more recent book on the right here, also by a Harvard professor, is looking at technologies that have nothing to do with energy, most of them, but show very interesting patterns as well. So when you look at the winemaking industry in France, for example, when coffee houses came along a few hundred years ago, I think about 400 years ago, the winemakers in France didn't like that, and they opposed it and ran adverts in newspapers. They lobbied the government. They said coffee drinking was bad for your health. Of course, none of that worked. We know where that ended, and everybody now drinks coffee. I think I had 4 or 5 cups today. It's probably a bit too much, a bit too excessive, but it hasn't worked. And there's still wine. People are still drinking wine, so actually both technologies exist alongside. Another example is the dairy industry. They didn't like margarine to come along, and they opposed margarine. And you find cartoons, when you Google it, like horrific cartoons, how margarine was supposedly made with all sorts of things going into these factories. So again, similar pattern, the incumbents opposing change, but it didn't really work. One final example, and then I move on to heat. So this is a much more contemporary example, and this is EVs and Tesla. Not that I'm a big Elon Musk fan, but in about 2015, the chairman of Daimler said publicly that he thinks Tesla is a complete joke. It's not a serious company, will never take off. Fast forward a few years, and which company was the most valuable car maker globally, worth more than all the other car companies combined? It was Tesla. Totally underestimated the rapidity of change, and the most sold model in the EU last year was the Model Y by Tesla. So again, this shows just how quickly things can change, and there's no means a given that energy systems require centuries. That's what Václav Smil is saying in his books, to transition from one energy system to another. I believe that they can change much faster. How does heat fit into all of this? And I think it's important to make this point again and again, especially for policymakers who do not often understand the basic data, and they think it's all about electricity. But it's not. This is the final energy use globally, and you see that about half of our energy use is actually for heat. That is industry, and that is buildings primarily. And what this means is that if we just talk about electricity, we're only going to scratch the surface in terms of decarbonization. Heat is really the biggest chunk of our energy use, and we have to decarbonize it. And that is still not very widely understood. The other factor is that we waste so much energy in the form of waste heat. Here's a Sankey diagram for Belgium. You can find it for any other country you want. There's a great website where you can get these diagrams by Lawrence Livermore National Laboratory. What I want you to focus on here is the top right corner. That's your waste heat. That's more than 2/3 or so of the energy that we put in on the left-hand side that just ends up as waste heat in the top right-hand side. And of course, all the energy on the left-hand side gets paid for. We pay for all the energy, but the services that we get in the bottom right corner, that's what people actually want. But they're paying, you could say, 3 times, 4 times more, because the way how we provide that energy is deeply inefficient. And you can, just to use an example, why that happens is, you could take any of the sectors, right? You could use electricity and burning coal for electricity generation. you get an efficiency of maybe 40%. The other 60% is waste heat. Or use the internal combustion engine vehicle. About 20% ends up as actually driving the car, the other 80% out of the window. And in heating systems, it's not quite as extreme, but take a gas boiler, maybe 80%, 85% efficiency. So huge potential for innovation and for doing things much more efficiently. And there's also so much heat all around us. I think that's the other point that I think is frequently misunderstood. The amount of heat that's in the water, in the ground, in the air, by far exceeds the heat that we need, to heat our buildings and for industrial processes. The challenge is how to harvest that heat, how to compress it, how to make it useful, bring it to the right temperature. But the amount of heat that's there is vast, and there's enough of it. The main way how to harvest that heat, of course, is to use technologies such as heat pumps as one of the key technologies that enable us to do that. And the good news is that electricity is now becoming a lot cleaner. This was a graphic that Nathan Bullard put together, I think about a month ago or so, and it went totally viral on X and LinkedIn. And what he showed is that for the first time, wind and solar now generate more electricity than fossil generators in the European energy system. And if you add other renewables to it and other low-carbon sources like nuclear, you end up actually having about 2/3 or more of electricity now being from low-carbon or no-carbon, zero-carbon sources in the electricity mix in Europe. So in other words, if we can use clean electricity and harvest that heat, we have a win-win situation, really. There are those, of course, in the gas industry who will say, no, it's going to be a totally different story. We have a gas network. We're going to replace the gas in the pipes with other gases, such as hydrogen. And I myself, I'm not a big believer in that. Actually, this is a tweet I put out when we cut our gas connection 5 years ago, I think it was, and we installed a heat pump. I would have loved district heating, but there is none in Oxford where I live, so heat pump was the only option, really. And it's a bit like saying with the gas network companies, I have a Ferrari-ready driveway. At some point, we're going to have hydrogen flowing through the pipes. When you look at the actual quantities of green hydrogen, of clean hydrogen globally, it's minuscule. There's almost nothing. And the idea that we can replace all that gas with green hydrogen, in my view, in the view of most experts, is simply ludicrous. It's not going to happen. So that's not going to happen. And indeed, the European Commission's own modeling shows that gas demand will drop substantially across the next 2 decades or so to meet the climate goals. There's no other way around this. And this includes hydrogen and biomethane and other gases. However, when you actually look at what the gas companies still project, you end up with this. This is from a recent report we put out last week, actually. And this shows in red the assumptions the gas grid operators in Germany are making about future gas demand. You can probably see where that line is going. It's going up, not down. And then at the bottom, you see the climate scenarios from the national climate scenarios in Germany that show how to meet those goals. There's a huge mismatch still. So we assume that in some countries still, the gas grid will be there in infinity. And of course, it won't. Unless you repurpose it. I sometimes get people on social media asking me, couldn't we put wires through it or use it for district heating? Probably very unlikely that you could use it for either of those two applications. I mean, there are other examples like phone boxes. You might remember some of those. Here's some from the UK. Some of them are quite entertaining. There's a public library, there's a fish tank. I think one guy made a fridge. There's some flowers, and there's many more you can find. Unlikely that we're going to find similar applications for the gas grid. And in fact, most of these phone boxes are simply gone. They've disappeared. And I think we're going to see the same for much of the gas network. The beautiful thing about district heating, which I'm going to come to next, is that, yes, we do have a lot of work to do in Europe in terms of cleaning up district heating, but we can, and that's different to the gas networks, we can actually use the same infrastructure and upgrade it and use it with other heat sources. That's a fundamental difference. It's unrealistic for gas networks, but it is the right way to go, I believe, for district heating. And why is district heating so unique? I think, again, this is misunderstood in a lot of policymaker circles. And that is, district heating has huge system benefits, which, in my view, go far beyond any of the other technology options that we have. You can do seasonal storage. You can integrate a very wide range of heat sources. And that makes managing not just the heating system easier, but also the electricity system, because we will need so much seasonal storage and flexibility going forward, that this is really a great solution if you can make it work. To give you an example of what that could look like, in Finland, there's currently a thermal storage facility under construction. I think it's 90 gigawatt hours. And there are many more. There are smaller ones already in existence. So heat storage is feasible. It's a lot cheaper than using electric storage. And it can be close to where you need it. It can be close to where the demand centers are. For example, district heating networks, and that's, I think, where the Finnish example fits in. It's actually used to heat buildings, or will be used to heat buildings. The other advantage is that you can use waste heat. And I talked to a few people in the break about waste heat. In theory, you could use a lot of the waste heat with heat pumps if you can get it from one place to another. There are some limitations to that. One is that not all of the waste heat is actually going to be there in 20 years, right? I mean, some of it will be from burning fossil fuels in industry, which will have to change how they manufacture goods, what fuels they're going to use. Some of the heat sources might be in locations where you actually can't use them, and they're too far away. But the principle still stands. If we can use at least a fraction of that waste heat and upcycle it with heat pumps, that's a great complement to the ambient heat that I talked about before. The potential is still very, very large. Currently, we only scratch the surface when we look at district heating. You all know this probably. This is now dated, but I think it's still very relevant. This is from Heat Roadmap Europe. And just to pick one example, the Netherlands here, which has a tiny fraction of district heat, 50% or so district heating would be possible. So the potential is very, very large. But we also have a lot of work to do with what we already got, right? We have to clean up existing district heating. And I think it's important not to shy away from saying that there is still a decarbonization problem. Right now, district heating is a decarbonization problem because we haven't cleaned it up yet. This is a fuel mix we currently use in Europe. It's a bit dated again, the data. This is from 2022 study, but the data goes back a little bit further even. And what you see is that most of it is still fossil fuels, and that's a problem. We're making some progress, and I think there was someone from Denmark earlier up here on the stage. Different countries have moved on this at different speeds, and when you see here how far some have come, in the top right corner, that's kind of the highest share of district heating and the highest share of renewables, you find the usual suspects, right? Denmark, Sweden, Finland, but also Lithuania and Estonia and Latvia, the sort of Baltic countries joining forces here too. So there are different examples where we already have a fairly high degree of decarbonization, but still the vast majority of systems are in dire need of upgrading. How can that be achieved? Well, here's a report that we've written last year, I think it was, on some of the policy principles. I'm not going to go through it. If you want to read it, I encourage you to read it. I think this is going to be too tedious to go through, and I don't have the time tonight. But there are a number of things that could be done to make more of district heating, both existing and new, and make sure that we use it for decarbonization. Looking at the clock, I have 3.5 minutes left, so I'm going to wrap up now. And I'm going to wrap up by just using 2 slides. The first one I'm going to use is a cartoon again, which I used at the beginning as well, but this one is a different one. It's so difficult in this discussion that we have, that is so highly polarized, to make a complex technology story fly, right? A lot of people will get their information from different channels that is not necessarily good evidence. And unfortunately, I think policymakers increasingly buy into that to some degree. We have seen that scaremongering, especially, Germany is the best example probably in 2023. Some of the things that were said in public, deeply unhelpful. And hopefully we can find a better story for district heating and clean district heating that will help persuade people and is based on evidence. And there are some great stories out there. This is my last slide. And this is an example from Austria. Puntigama is, I'm not sure I pronounced that correctly. It's a brewery, and the interesting thing here is that the waste heat from this brewery actually ends up in the buildings around it. So the beautiful thing is you can drink a chilled beer coming out of that brewery in your home that's heated with the waste heat from the beer that you're drinking. And I just love that analogy, thinking I'll be sitting there after work, enjoying my beer, and then looking out of the window and seeing kind of where the waste heat comes from that keeps me warm, and also where the beers come from. So there's some great examples like that, and I think they bring it much more to life and make it more real. I think we got to find more of these stories so people can relate to district heating, relate to heat pumps, relate to using waste heat much more than I think they currently do. I stop here, and I'm glad for any questions or comments if we have time. Thank you.
Thank you very much, Jan. I think we will need to exit soon, but that would be a shame not to allow for at least 1 or 2 questions. So just looking to the audience. Anyone has a question for Jan? Yes, I see one.
Hello, Jan. I don't know if you remember me, but I hope to meet you in Copenhagen again and have a beer or two. Jan, what do you think about the future of biomass in this context when you showed the matrix there? Thanks.
Sorry, about the future? I didn't quite...
Of the future of biomass.
Oh, the future of biomass. Oh, thorny issue. Difficult question. No, I think there's a limitation how much you can do with biomass. And some biomass is more sustainable than others, and it's a really difficult discussion. I personally don't think that biomass is the solution for a lot of countries where you simply have limited resources. I mean, it's different in Sweden, right, or Finland, where you have very large sort of woodlands and things like that. But it's much more difficult to envisage, for example, in the UK, where would that biomass actually come from? You would have to import it from overseas. And already we are running into issues with Drax, and we are from a coal power plant that's now running on biomass. So I would be cautiously skeptical when it comes to biomass. I'm not saying it's all bad, there is a role for it, but I don't think that is the core of the decarbonization strategy. I'm more on the side of using electrification and using waste heat that is unavoidable in combination and ambient heat rather than rely on biomass. But there is a role for biomass, no doubt, but I don't think it's the core of the decarbonization strategy for district heating.
Thank you.
See another question there, yes?
Yes, thank you, Jan. Very inspiring presentation. And maybe almost the same question, but what do you think about excess heat from nuclear power plants? So could it be treated as a useful and reliable source? Thank you.
Yeah, why not? I mean, I don't have a strong view on nuclear and that I want to share here. I think there will be some nuclear in the mix, right? So if there's waste heat and you can use it, why not use it? Better than just letting it go up into the atmosphere, right?
Maybe, yeah, I see one question there. It's going to be the last. God, we need to make the whole... Sorry. You're doing great.
A question on, I guess, on synergies in general. I think when we look back on when we were rolling out infrastructure like power grid or the gas grid 40, 50, 60 years ago, we were adding new functionality to the system. So I guess that made people excited, right? I think one of the challenges with energy transition is that often for the end user, we're not necessarily adding new functionality. So do you see, or do you have ideas of what sort of new type of functionality we could add? One of the things I think from the cooling discussion we just had, I think with air-to-air heat pumps, for example, that might be an argument, right, to switch over, that if they're reversible, that they give the cooling functionality that you might not have had before. So maybe building on that, do you see other sort of new functionalities that we could that can help accelerate adoption of decarbonization technologies?
Great question. Yeah, I mean, cooling is the obvious one, right? But I think there's something else with district heating. People like communal heating systems, it seems. When you look at public surveys, people like the idea of sharing infrastructure for heating. More generally, they actually prefer it to individualized solutions, which is interesting. And they also don't like wasting heat. So integrating waste heat in district heating is something people value. So it's maybe not so much a material, like except for cooling, not a material improvement. You're still getting heat delivered, right? And modern heating systems are pretty good in delivering heat, even if they burn fossil fuels and emit carbon emissions, but they do it pretty well. So I don't think you can provide something extra, right? The heat is just going to be the same. But I think there's something more going on there, values you can tap into by providing these solutions that people actually like and endorse and are maybe even willing to pay a premium for because they like the idea of a shared asset that they're part of.
Thank you very much, Jan. Please, once again, a big round of applause.
Thank you.